For this example, we want to find the average rate of change. Average rate of change is a new-ish phrase, but an old concept. You have done average rate of change before. Anytime that you ever calculated the slope, you calculated the average rate of change. We have a formula for slope. y2 minus y1 over x2 minus x1. We just need 2 points. We plug them into the formula, and then we have the slope or the average rate of change. In this problem, they did not give us 2 points. What they did do is they gave us an equation, and then they gave us an interval. We want to see what the average rate of change is when we go from an x value of -2 to an x value of 5. So both of those values there are x values. Essentially, what they are saying is you have 2 points in this problem. One of them is the point -2 comma something. We'll have to figure out what this y coordinate is. And then the other point is 5 comma something, and we'll have to figure out what that y coordinate is. So they've given us 2 x values for our 2 points. We have to calculate the 2 y values. But that's pretty easy to do because they gave us an equation for us to work with. If we are going to plug in a -2 for x, that would be a -2 squared plus 5 times -2 plus 6. And if we calculate that value, -2 squared is 4, and then we would have that negative in front, so that's a -4. 5 times -2 is -10. So -4 plus a -10 is -14, plus 6 is -8. So when we plug in a -2 for x, we get a -8 out for y. So one of our ordered pairs that we're going to have to plug into our slope formula is the point -2, -8. We also need to figure out the y coordinate at 5. So I'm going to plug in 5 for x. Five squared is 25, and then we have the negative in front, so that's a -25 plus 25 plus 6. That is equal to 6. So when we plug in 5 for x, we get 6 out for y. If this is a linear algebra course, they would have said find the slope of the line going through these 2 points. For pre-calculus, we are looking at finding the average rate of change. They gave us 2 x's that we had to plug in to figure out our y values, but now from here to the end of the problem, we just need to take these values and plug them into our slope formula. So our slope formula again is y2 minus y1 over x2 minus x1. Here are our 2 values. Each of these is an x and a y coordinate. One of them is point number 1, one of them is point number 2. Doesn't matter which is which. I'm just going to do these from left to right. So I'm going to let this be my first point. So this is x1 and y1. This is my second point, so I'm going to let that be x2 and y2. And now I can just go through and substitute those values into the formula. So on the top, we have y2 minus y1, which would be 6 minus a -8. And then in the bottom, x2 minus x1 would be 5 minus a -2. If I evaluate that, minus a negative is the same as plus, so 6 plus 8 is 14, 5 plus 2 is 7, and if I reduce that fraction down, we actually get an integer on this problem. So the average rate of change for this equation from an x-coordinate of -2 to an x-coordinate of 5 is 2. It is the same as our slope.